Today we will be beginning Chapter 3 on describing, exploring, and comparing data. A lot of the first section here will be review because I know many of you have been finding mean, median, mode for many years now, but we hope to expand this just a little bit so that you are adding something new to what you know about it. Okay, as I said, the focus of this section is to be able to obtain a value that measures the center of a data set, and those that I just referenced with mean, median, mode are those measures of center. So we'll look at those three, and in addition to that, the mid-range as well. So we want to not only just be able to find those measures of center, but we also want to be able to interpret those values. Okay, so our four measures of center are the mean, median, mode, and mid-range, the four M's. So the mean is the sum of the values divided by the number of values. Median is the middle value or the average of the two middle values. The mode is the most frequently occurring. And the mid-range is you add up the maximum and minimum values and divide by 2. So we're going to go through some examples of these and just make sure that you're comfortable with those, and also look at how to do them on your graphing calculator as well as StatCrunch. Okay, the mean, also referred to as the arithmetic mean, is the for a set of data is the measure of the center found by adding all the data values and dividing the total by the total number of data values. So if we look at this is a symbol that you should know. If you don't know it, then you will by the end of the semester, and the sooner the better. So this is X bar, and X bar is going to be our sample mean. So if we're talking about a sample mean, then that's going to be the sum of our data values. So we represent the summation with this Greek symbol here for summation. So the sum of our data values divided by n, and n is our sample size or the number of the data values. Okay, so some things to consider here. Sample means drawn from the same population tend to vary less than other measures of center, and that's one reason you see a lot of times means are reported, because they don't vary as much from one sample to the other as long as they're coming from the same population. The mean of a data set actually uses every data value. So like if I'm calculating, for instance, the median, I'm not going to take into account every single value, so to speak. Just like the mean will take into account all the different values. One disadvantage is that if you happen to have an extreme outlier, that outlier might be a legitimate value, or it might be a typo or something with the data. But if you do have an outlier in there, it can drastically affect the value of the mean. And therefore, we say that the mean is not resistant because of that. Okay, so when we talk about something being resistant, a statistic being resistant, it's resistant if the presence of an extreme value like an outlier does not cause it to change very much. So it's stable, kind of another way of thinking of it. It doesn't have an extreme effect on it. Okay, so notation, like we mentioned, we've got our summation notation. The X is going to represent the individual data values. The lowercase n represents the number of data values in a sample. And then we don't use it very much, but the capital N actually represents the number of data values in a population. So be sure that you know these and know them well. Okay, some others that you need to be familiar with. We already mentioned X bar, but I'm also going to mention mu. Mu, you'll hear me refer to throughout the semester, and it's the sum of the data values divided by the population sample, by the population size. So in some cases, our population is small enough that we actually are able to work with the entire population. In that case, then we would use mu, and we would be able to know what our population size is. So for instance, if our population was the Wingate football team, that's a small enough population that we would actually know how many members there are in the population. So that would be a case where you would use the capital N. So if we're talking about a sample mean, you're going to reuse the symbol X bar to refer to that. And if you're talking about a population mean, you're going to use the symbol mu to refer to that. Okay, so moving right along here, we have this data set that is going to reference the data speeds for Verizon. And what we're going to be trying to find here is we want to find the mean of these first five data values. that are coming off. It's actually coming off of a larger list here. But looking at these 5, if we're going to find the mean, we know that we just need to add those up. So we're going to add all of them up, divide by 5, and we're going to get our mean for that. So this would be our X bar for our sample. Okay, oh, just kind of a word of warning. Average is basically a slang word when you're talking about it in a statistics class. So we're going to refer to it as the mean and not the average, because average is not really going to be a professional word that's used by statisticians. It's not going to be used in professional journals or the statistics community. So we really want to refrain from using average and instead use the mean in the place of that. Okay, so a couple other properties here with the median. The median is our second measure of center. One thing about the median is it is more stable and not resistant to those extreme values like the mean is, mainly because we're focused on the center of the data set and the values near the center, so it doesn't really take into effect those outlier values. We don't actually use directly every data value, so so a large value is not going to change the median value very much. Okay, we do have some symbols for this. You don't see these quite as often as the X bar and the mu, but X tilde or the capital M represents the median. So one thing that's very important when you're finding the median is make sure the values are sorted. If they're not sorted, then that needs to be your first step in doing any problem. If the number of data values is an odd number, then you're going to go to the very middle data value, and that's going to be your median. If the number of data values is an even number, then you're going to take the middle 2 values and find the mean of the middle 2 values. Okay, so for this one, if we've got 5 data values here, so the first thing we would want to do is put those in order. So make sure they're in order and then take your middle value because we have an odd number. That's going to be the median. Okay, here if we add the 24.5 to this list and then put it in order again, we're going to have to, we've got 6 values now, so an even number, so we need to take these middle 2 values and find the mean of those, and that's going to give us the median for this data set here. Okay. All right, the third measure of center is the mode. The mode is of a data set is the value or values that occurs with the greatest frequency. So basically, when we look at a data set, whatever is occurring the most frequently is going to be the mode. The mode can be found with qualitative data as well, and it is possible to have no mode. You can have one mode, you can have more than one mode, or it can be multiple modes. So we're going to look at a couple examples of those. The first one here, if you have, or just a couple other definitions, if you have 2 modes, it's referred to as bimodal. If you have multiple modes that occur the same number of times, then it's multimodal. But when you have no data value that's repeated, and that's actually the case a lot of times in real data sets that we don't have repetition, that would be a case where it would be no mode for your answer. Okay, looking at this small data set here, we've got 0.3 is the value that occurs most frequently. So this one only has one mode, and that mode would be the 0.3. If we look at this data set, we've got 0.3 that occurs twice, and we have 4 that occurs twice as well. So this would be bimodal and have 2 modes. Of one mode would be 0.3, the other mode would be 4.0. And then if we look at this data set, nothing repeats, so this would be one that has no mode. Okay, the mid-range is the measure of center that's the value midway between the maximum and minimum values. It's found by adding the maximum and minimum and dividing by 2. So our formula is listed here. So take your largest value and your smallest value, add them together, and divide by 2. Okay, one problem that we run into is that the mid-range is not resistant to outliers. Okay, so it's very sensitive to extreme values. Because if we look back, we would actually be using one of those extreme values as its maximum or minimum. Therefore, the whole basis of this mid-range calculation is based off of an outlier. And that's one reason we don't see the mid-range used as frequently as mean, median, and mode, is that it just doesn't, it's just very susceptible to those outliers, and it's not a great indication of the measure of center. Okay, so a couple properties of the mid-range. The mid-range is easy to compute because it's just maximum plus minimum divided by 2. It does reinforce that there are several different ways to define the center of a data set. So we get kind of to thinking that the mean is the only measure of center, and it's not. I mean, the mode, the mid-range, the median, all those are measures of center. So in some way, they give us some indication of where the center of the data set is, but it's just not the best one, and that's why you don't see it very often. Sometimes it's simply reported so that to alleviate confusion between the median and the mid-range, and kind of make that distinction. Okay, so if we were to calculate the mid-range for this data set, the first thing we want to do is make sure that we've put it in order. So it's a small enough data set, we can easily see our smallest value is 14.1 and our largest is 55.6. So we'll add the maximum and the minimum value, divide by 2, and we end up with our mid-range for that. Okay, rounding rules. We will start to have a lot of rounding rules. So I would really just suggest that you find a place in your notebook that you can start this list of rounding rules and add to it as we go, because it is important that you know how to round correctly. So if you're calculating mean, median, or mid-range, what our rule is that we're going to carry our answer one more decimal place than is present in the original set of data values. Okay, we don't do that for the mode because the mode is actually going to be one of the data values. We're not going to be making a calculation in order to get the mode, and therefore we don't really have to worry about rounding because of it. But for the mean, the median, and the mid-range, you do need to apply this rounding rule to that. So if I look at this data set here, I have 2 decimal places shown. So when I go through and I do calculate the mean for those and report my answer, I need to go 1 decimal more than this. So if I have 2 that's shown here, I'm going to give my answer to 3 decimals. On this one, I have 1 decimal place shown. So because I have 1 decimal place shown, I'm actually going to go 1 more decimal place than that when I report my mean, median, or mid-range. And so I'm going to round those answers to 2 decimal places. This data set has whole numbers, so it has no decimals shown. So when I actually report my answer, I'm going to report it to showing 1 decimal place for my answer. So just remember, it's always 1 more decimal place than your original data set. Okay, so here's one for you to practice with. If you want to pause this and take a minute, figure out what the mean, median, mode, and mid-range would be, and then you can check your answers. Okay, you should have gotten these as your answers. The mean here would be 69.2. The median, the mode is going to be the third one here. And so the mode is going to be bimodal with 62 and 72. And then the mid-range is also going to be 72. Okay, it is in order. If it happened not to have been in order, you would need to make sure that it was. Okay, so looking at this, what happens with an outlier? If we take this same data set and enter this, and then we add 1,000 to it, so we're adding one additional value that's clearly an outlier here. I want you to go through and recalculate the mean, median, mode, and mid-range and see what the effects are of this. Okay, if you've calculated those, you see that the mean changes to 153.8. The median is 71. The mode actually stays exactly the same, and the mid-range goes all the way up to 530.5. So clearly the mid-range was the one that was affected the most, but the the mean also was affected pretty greatly. The median was slightly affected because it was 68.5 and now it's 71, so it was slightly affected. The mode stayed exactly the same because an outlier is not going to show up as a mode because of the way a mode is defined. So your least resistant measures of center are going to be your mid-range and your mean. Okay, I've hopped over to the TI-84 calculator because I want to show you how to enter data sets in your calculator and find these measures of center. So the first thing we want to do is we want to go in and actually enter our data values just as we've done before from chapter 2. So if we go all the way up and clear these out. Okay, hopefully you were able to get the data cleared out. So all you need to do is go all the way up to the top and highlight the L1 or L2 and press clear and then enter, and it'll take everything out. So we want to enter the data set here. So we're just going to go with the one that I have shown on the side. We're going to have 61, 62, 62, 64, 66, 71, 72, 72, 79, 83, and 1000. Okay, so we should have 11 data values there. All right, so what we want to do from here is to go to Stat. And this time we're going to actually go over to Calculate. And we're going to choose number 1 for one variable stats. We want to make sure that we've put the data set in the list that's showing here. So if you didn't put your data in L1, you need to change that. Press Calculate. And enter. Okay, and so we come up with a whole list of statistics for us to look at. The first one is X bar, so this is the mean, and that's what we found here was the 153.8. If you scroll down, we're going to see the median. Okay, so we'll see the median is 71. It's not going to tell us the mode directly, and it's not going to tell us the mid-range, but it does tell us the maximum and the minimum. So on a data set this size of like 11, that's not that important. But if you have like 50 or 100 data values, it's really helpful for it to identify your maximum and minimum for you instead of having to go through and compare that. So as far as the mode goes, what I would suggest doing is going to your stat and edit. Actually, we're going to sort. Okay, so let's sort. And we've done some sorting before. So let's sort L1. So we'll do second and number 1. And we'll sort L1 and enter. And then we're going to go back to stat and edit. And what it's done, this data set actually was already in order, so I didn't really need to do that. But if it weren't in order, it would sort it for you. So it's pretty easy from this sorted list to go in and figure out what the mode is with this. So if we look at it, you can see 62 is occurring twice and 72 is occurring twice. Again, it's not that important for a small data set like this, but a really large data set, that can be very helpful to do. Okay, next I'd like to hop over here to my stat lab and take a look at StatCrunch. So remember, access StatCrunch from the left side. We'll go to our StatCrunch website and open StatCrunch. And I've already pre-entered a data set that I'm going to work with here. So I'm going to load my data, and it's the same data set that we were actually just working with now. So that was the temperature example. Okay, so we have these data values here. If we want to come up with the summary statistics for this, we're going to go to stat, and then we're going to go to summary stats, and we want to do columns. Okay, so we only have one column here, but it's very likely that you may pull up data sets that have multiple columns. So it's going to give us some options to choose from, and you can select multiple options here. So if I want the sample size, that's going to be the N. So what I want to do is go in and highlight N for sample size. If I want the mean, then I'm going to use my control key and highlight that one as well. And then we have some others down here that we can take a look at. I'm having some trouble getting them all to stay, but we've got the median, we've got our minimum, we've got our maximum, and then some of these others we're going to talk about later, and then your mode is down here at the bottom. So let's just do one where we do the mean, and we're going to go through and compute. And so you can see it pops up with this little screen over to the side, and it's got the mean for that particular data set. So it's very easy to work with really large data sets in StatCrunch. So you could easily have a couple hundred data values and easily find your mean, your median, mode by going through. So remember that stat and then summary stats. So you're going to need some of this information for your next StatCrunch lab as well. So stat, summary stats, and then we've got go to columns, and then you'll have your choices here. Okay, back to the PowerPoint slide presentation. I do have a couple screens in here that list the steps for using the calculator. Okay, back to the PowerPoint slideshow presentation. I do have a couple slides in here for using your calculator, which you can see here. And I also have the steps for doing your StatCrunch as well. So you may want to pull up the PowerPoint slide after watching the video if you need any additional help with that. Okay, so what I have here are two data sets that I would like for you to practice with. The first data set is the security company, and then you've got the other companies. So in this particular example, these are representing millions of dollars that are collected from parking meters by a security company in a certain city. And a larger data set was actually used to convict 5 members of the company of grand larceny. So what I want you to do is for each of these, for the security company and then for the other companies, I want you to find the mean and find the median and then compare the results between each of these. So compare the security company mean to the other companies and compare the security company medians to the other companies, and then see if you can answer the questions. Do these values listed here show evidence of stealing by the security company's employees? Okay, after you've put this in L1 and found your mean, your median, um, for comparison purposes here, if we look at the security company versus the other company, these are the means and medians that you should have gotten. And with this, you can see that there is a discrepancy, that the security values are significantly lower than the other values. So there does appear to possibly be evidence of stealing by the security company's employees with that. One thing I want to mention is going back to rounding, these are our data sets here had 1 decimal place shown. So notice that I did go ahead and show that second decimal place for the mean when I was calculating that. Okay, here's another example that I'd like for you to do the same thing with. These are talking about wait times in minutes of customers at a bank. One has the customers all enter with a single line and wait in a single line. Another has individual lines. So I want you to compare the measures of center for these two. So you'll need to identify all 4 of these, the mean, the median, the mode, and the mid-range. I know it's easy to continue just watching the video and let me do the work, but you really need to practice putting these in and making sure that you can come up with the answers that I'm going to be showing you. Okay, when you come up with the measures of center that I ask you to find here, and I also ask for the mid-range. Okay, now that I have all of them written here, what you can see is that our measures of center for these two data sets are actually exactly the same, which seems a little unusual that we could come up with the same mean, median, mode, and mid-range for 2 different data sets. But it's just kind of showing you that 2 separate data sets can have very similar measures of center, but yet look very different. Because if you notice here with the single line, versus the individual lines, what you should notice is that the single line data values are much more concentrated around the measures of center, whereas the individual lines vary significantly. Maybe you get lucky and you get in and out of the bank in 4.3 minutes, but you also might get stuck behind somebody that's taking forever and end up waiting 9.7 minutes. So there's a lot more variability here with these values in the individual lines, but the single line values is much more consistent. So we see these measures of center being the same, but the spread of our data or the variability in the data is very different. Okay, so when we talk about which ones are most resistant to outliers, we've already mentioned that the mean and the mid-range are not very resistant. They're greatly affected by the outliers. the mode and the median are more resistant to those. So here's an example that I would like for you to think about. So pause the video and take a minute to address A and B and see what your answers would be. Okay, if we're looking at theater A, if we look here, our mean is 75.6 and our median is 90. So when you look at this mean, it's actually below 4 of the data values here. And this mean is being affected pretty significantly by this outlier that we have on day 4. We don't really know if this is a typo and maybe it should have been 100, or maybe there was a problem at the theater and they didn't have a lot of people there. Maybe it was really pretty outside and nobody went to the movies that day. We just don't know the story behind this, but we do know it's significantly affecting the mean. So for theater A, the better measure of center would be the median. For theater B, our values all seem to be fairly similar, so the mean would be an acceptable value to represent the measure of center for that one. So we can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that, because sometimes it really doesn't give us anything when we do those calculations. We also need to think about what type of sampling method was used in collecting the data, because that's important as well. Okay, for instance, here we've got zip codes. It really wouldn't make any sense to find the mean of the zip codes. There's nothing valuable in doing that. So those are just not meaningful statistics. Okay, same thing here. If you've got rankings of universities, that's not going to give us any type of measure or any kind of data that would be helpful by averaging the rankings of that. So we want to make sure that we're using our critical thinking skills and not just routinely manipulating numbers, but actually having a reason for doing what we're doing. Okay, there's two concepts left that I would like to look at, and the first one is finding the mean of a frequency distribution. So we have a formula here for finding the mean of a frequency distribution, and that is we're going to have the sum of the frequencies times the data values divided by the sum of the frequencies. So that looks a little foreign to us, so I want to work through an example and show you what you would need to do with this. Okay, here we have an example that we're going to be working with. You have your frequency distribution. One thing I want to point out is when you have a data set, you have your actual data values. So you can add them all up and divide by the total and get the mean. But when you have a frequency distribution, we don't really have the exact data values. For instance, on this first class, we know there's one value between 20 and 29. We don't know what the value is. We don't know if it's 20, if it's 29, if 27. We don't know. And so we have to use an approximation for doing this. And so what we're going to use is our best estimate for this particular first class is going to be the class midpoint. So we need to go through and find the class midpoint for each one of these classes here. Okay, so our class midpoint on this one, we're going to add the 20 and the 29 together, and we're going to get 24.5. We're going to go through and do the same thing here, and we'll have 34.5, and then we're going to have 44.5, 54.5, 64.5, and 74.5. So these are going to be kind of like our representative values for this interval, because we need a value in here that represents it, and the class midpoint makes the most sense to do that. So the next thing we're going to do is we're actually going to go through and multiply. These are multiplication symbols, not x's. So we're going to multiply 1 times the class midpoint, and we're going to put that over here. So 1 times 24.5 is going to give me 24.5. Next, we're going to multiply 26 times 34.5, and when I do that, I'm going to get 897. Then I'll multiply 35 times 44.5. I'll get 1,557.5. The next one, multiplying across, I'll get 708.5, and then 387, and then 74.5. Okay, if you think about when you find a mean, you add all your values up and then you divide by the total. So that's kind of what we're going to do next. We're going to take these values and add them all up. And so when I do that, I get 3,649. So next I want to take that 3,649 and divide it by the number of values. Okay, so to get our number of values, we're actually going to come over here to our frequency column and add those up. So if I add all of these up, I'm going to get 82 for my value, and that's what's going to go down here. That's what I'm going to divide by. So I'll get 44.5. So that's the mean for this frequency distribution. If you notice, 44.5 is in this class here. So it actually makes sense that our mean would be in this class, because if you look at our data, that class has the largest frequency, and therefore we would expect the center or the mean to be in that class. Okay, here's another one for you to practice. So pause this and practice this one. Go through the same process that we just completed, and then check your work in just a minute. Okay, so this is what you should have gotten here. We want to find the class midpoint for each of these by adding them up and dividing by 2. And then we're going to multiply the frequency times the class midpoint, and you'll get these values here. Then we're going to add all of these up and get this total. And then once we get this total, we need to divide it by the frequency. So we're going to divide it by the 50. And so we're going to have 8,025, divide that by the 50, and we're going to get, okay, so we're going to get 160.5 for our answer on this one. Okay, so looking at 160.5, that actually puts us here in this class, and that's kind of what we would expect because that's our largest class. So we would expect our mean to be somewhere in here with that. Okay, the other concept that I'd like to finish with here is calculating a weighted mean. Weighted means are used for GPA. It'll be used for taking this class because, like in the class, and when we figure that the grade for the class, your test count 50%, your homework counts 20%, and so forth. So everything counts a different percentage. So a test is not counting equal to a homework and so forth. And so we have to weight that to do it. Okay, the first thing I want to show is an example of calculating GPA, because every college student should know how to calculate GPA. And with GPA, we have what's called our quality points. So with our quality points, if you make an A, you're going to get 4 quality points. A B, you're going to get 3. A C, you'll get 2. A D, you'll get 1. And an F, you'll get 0. So that's an important part. That's going to kind of be a grade translation that we're going to make. The other thing is your credits. Your credits are going to serve as your weights when calculating the GPA, because like if you have a 3 credit hour class like this class, in fact, most classes are 3 credit hour classes. They're not going to count the same as like a 4 credit hour class like biology or calculus or some of those, or even a 1 credit hour class like gateway or maybe PE. So if you make an A in calculus, that's a lot better than making an A in PE as far as calculating on your GPA goes. So what we're going to do is we're going to look at taking for each one of our grades here, we're going to take the quality points and multiply it by the weight or the credit. So for this grade of an A, this person is going to get a quality point of 4 and it's in a 3 credit hour course. So the weight of it's going to be a 3. For our next class here, we have another A. So they're going to get a 4 on their quality points, and they're going to get a 4 on their weighting or credits. The B, they get a 3 on their quality points and a 3 on their weighting or credits. The C, they're going to get 2 quality points and a weight of 3. And then the F, they're going to get 0 quality points and a weight of 1. Okay, we're going to go through, we're going to divide this by the total number of credits. So if we add all of these credits up here, this particular person had 14 credit hours. Okay, so that's what we're going to divide by here. This 14 is going to come and be the denominator for this. So when we add all of this up and then divide it by 14, we're going to get 3.07. Typically, GPAs are reported to 2 decimal places. Mathematically speaking, using the rounding rules we've talked about, you would report it at 3.1, but sometimes conventional reporting will trump the mathematical rules that we've learned, and GPA would be one of those. Okay, so here's a few slides to kind of go through and further explain what we just talked about. Again, these are available as part of your PowerPoint. Okay, the other example that I want to look at is calculating your grade in this class. Okay, so your grade in my class is calculated as follows: 50% test, 20% online homework, 15% final exam, and 15% quizzes. So you have 4 tests. Okay, so our 4 tests, these are the grades that this person has. So this person has a 95, an 83, a 72, and a 65. So we've got to go through and find the mean of the test. So when we look at the mean, finding the mean of the test, we're going to find that that is 78.75. Okay, now we want to find the overall average or mean in the class. So this is the part that's going to be weighted. Our tests were not weighted because all the tests count the same, but the actual mean in the class is weighted. So when we look at tests we said were weighted at 50%, so we're going to have 0.50, and the value for the test, or the mean for the test, was 78.75. And then we've got, next, we're going to do our homework, and the weight of the homework is 20%, and this person had a homework grade of 95, or an average, mean homework grade of 95. Okay, let's do the quizzes next. So the quizzes in this class count 15%, so 0.15, and the mean for the quizzes is 75. And then finally, the final exam. The final exam counts 15% as well. And the person here on the final exam had a grade of 82. Okay, if you go through and multiply all of this out, you end up with an 81.275. So an 81 for the class. So this person would make a B in the class. So this would be an example of a weighted mean where everything's not counting the same. So you need to make sure you have your weighting, and then you have the value for that for test or homework or whatever.